Hi there, in this video we are going to solve practice problem 7.1 from Fundamentals of Electric Circuits 5th edition. You can see that we have been given with a source free RC series circuit because there is no external voltage or current source connected to the circuit. So there is a 12 ohm resistor in parallel with a 6 ohm resistor, an 8 ohm resistor and a capacitor of capacitance 1 divided by 3 farad, right? We have also been given with the initial capacitor voltage, that is Vc at 0 seconds, and it is given as 60 volts. We have to find the capacitor voltage Vc, the voltage Vx across the 6 ohm resistor, and the current I0 flowing through the 8 ohm resistor at time greater than or equal to 0 seconds. This question is about the natural response of the RC series circuit, and by natural response we mean that the circuit is able to perform work without any external voltage or current source, right? In this case the natural response is due to the initial charge, or you can say that initial voltage stored by the capacitor. Here we have been given with the initial voltage, that is 60 volts, right? So to solve this question, we have to determine the time constant for it first. So time constant is the time required for maximum charging and discharging of the capacitor, and for a time period of one time constant, right, the maximum charge that can be stored by capacitor is 63%, or the minimum charge that can be stored is 37%. So let's find the time constant. The symbol tau equal to RC, and you can see that we have been given with the resistors that are in different combinations, so we have to find the equivalent of these resistors. So the 12 ohm and 6 ohm resistors are parallel to each other, so let's find their equivalent first. Let's name their equivalent as R1. So R1 equal to 12 into 6, right, divided by 12 plus 6, so it will give us 72 divided by 18. Simplifying it will give us 4 ohms, that is the equivalent of these two parallel capacitors, sorry, resistors, right? Now redrawing the circuit, let's draw it here to save some space. So the equivalent resistor is here, the 8 ohm resistor and the capacitor. So 4 ohms, 8 ohms, the resistor. So these two resistors are now in series, you can see that, so we can simply add them up. So our final simplified circuit will be like this. The capacitor in series with the equivalent resistance, so 8 plus 4 will be 12 ohms, and the capacitor is 1 divided by 3 farad. So here we have an RC series circuit, right? So we can put the values in the equation of time constant. So tau will be equal to 12 multiplied by 1 by 3, right? So our time constant will be 4 seconds, right? So we will put this value of time constant in the equation of capacitor's voltage Vc at time t. So the capacitor voltage Vc at any time t is equal to the capacitor voltage at 0 second, that is the initial capacitor voltage Vc at 0, into E raised to the power minus t divided by Rc, where Rc is a time constant we have already calculated it. So Rc equal to tau. So now simply putting the values, so Vc at 0 is 60 into E raised to the power minus t divided by 4. So our final simplified answer for capacitor voltage at time t will be 60 into E raised to the power minus 0.25 t volts. So this is the answer for capacitor voltage at time t, right? Now to calculate the voltage Vx, that is across the 6 ohm resistor, this is our capacitor voltage at any time t. Now we will simplify the circuit a bit, right? So you can see that this voltage is being divided into the 8 ohm resistor and the parallel of these two resistors, that are 6 ohms and 12 ohm, right? So we will find the parallel of these two resistors and we will find Vx because these two resistors are in parallel, so the voltage across them will be same. So let's redraw the circuit. Here will be our equivalent of these two parallel resistors, right? Here is our other resistor, the capacitor here, 1 divided by 3 farad, or the voltage Vc at t, right? And 8 ohm resistor here, the current I naught is flowing through it, and the equivalent of these two resistors we have already found it. So it was 4 ohms, right? So the voltage across this resistor will be Vx because the two resistors were in parallel, so the voltage across them was same. So we can use voltage division here because the capacitor is acting as a source here. So using voltage division, because these two resistors were in series and voltage is being divided among these two resistors, so Vx at time t will be equal to the source voltage, in this case that is 60 into e raised to power minus 2 minus 0.25 t, sorry, multiplied by the resistor across which we have to find the voltage, that is 4 ohms, divided by 8 plus 4, right? Now we can simply put it in the calculator. So 60 into 4 divided by 8 plus 4, so it will give us our answer for the voltage across the 6 ohm resistor, that is Vx at time t. So it will be 20 into e raised to the power minus 0.25 t volts. Now the only thing that is remaining is the value of I naught. We can simply find it by applying Ohm's law, because you can see that the circuit is now in series form, right? And the current flowing through it is I naught, so we can apply Ohm's law on the 4 ohm resistor and we can find I naught. So simply applying Ohm's law on the 4 ohm resistor, let's make a partition here. So using Ohm's law on the 4 ohm resistor, so I naught will be equal to Vx divided by 4, right? Simple Ohm's law. So Vx was 20 into e raised to power minus 0.25 t, 0.25 t divided by 4. Let's simplify it a bit. So 4 ones are 4, 4 fives are 20. So our current I naught at time t will be equal to 5 into e raised to power minus 0.25 t amperes, right?